like to do is I'd like to boil the water in the witch's cauldron. All right, this is definitely seasonally appropriate since we're approaching Halloween, and we'll work it out fully next time. Now, I'm going to introduce another feature into the problem, and this is the one that I want you to understand now. We'll set it all up tomorrow, but right now I need you to understand what the new main idea that we're going to get. Okay? There's the new physical feature that I'm going to add to this problem is that when you're boiling, when the witches are boiling this water, the temperature of the water is not the same at each level in the kettle. At the bottom of the kettle where you're heating it up, it's at its highest temperature. So at the bottom, it's going to be, say, 100 degrees. That is, it's going to be totally boiling, 100 degrees Celsius. And at the top, it's going to be, say, 70 degrees. Right, it's very cold outside. In fact, it's 0 degrees outside, which is the temperature at which all witches operate, I think. Anyway, so they're boiling their stuff. And the question that we're going to ask is how much heat do they need to do it? Now, the thing starts out at 0 degrees Celsius, and we're going to heat it up to this temperature configuration here. But it's rising from 100 down here to 70 up here. So the temperature is varying in height. And for simplicity, I'm going to make the formula for the temperature be 100 at the top and 70 at the 70 at the top and 100 at the bottom. So it's going to be 100 minus 30y. We'll let the level be 1 here. 30. I said 3. I wrote 3, but I meant 30. All right? So this is the situation that we have. Now, the point about this problem is we're going to figure out the total temperature, the total amount of heat that you need to add in order to heat this thing up. That's going to be temperature times volume. But some places will count more than others. These will be hotter, but there's less water down here. This is wider up here, so there's more water up here. So there are various things that are varying in this problem. Now, the only way to set it up so that it works is to chop things up horizontally instead of vertically, because it's on the horizontal levels that the temperature is constant. So we'll have an easy calculation for how much it takes to heat up a layer, a horizontal layer. When we rotate this guy around the y-axis, that is which kind of shape? It's a disk. So actually this is going to be an easier problem. This is going to be a disk problem, not a shell problem. But we're going to have to work things out with respect to the dy variation. In other words, the integral will be with respect to dy. So we will do that next time. We'll figure out how much heat it takes to boil the kettle.